Hello and welcome. In this video I want to talk a little about data analysis. So I have on the left what an absorbance plot might look like. This is one of the absorbance scans of potassium dichromate as a function of wavelength. So this is the dichromate not yet reacting, so this is just dichromate in water, maybe with the presence of some acid, which it's relatively stable, doesn't quite react, or at least react very quickly in that solution. Then we add some alcohol to the solution, add methanol, ethanol, isopropanol, 1-propanol, something like that. Then we can get a reaction to take place. So this, I believe, was sitting at 450 nanometers. And so we're sitting at 450 nanometers now. As a function of time, we can see the decay and the loss of the absorbance of potassium dichromate. I think we're following it with this peak here. So if you're looking at the absorbance file, we're actually using this peak here. You could follow at 350 or at 450 and generally see the same decay for the loss of dichromate signal as a function of time. Okay, now there's a couple ways to actually work up our data here. One of them is to actually just run I guess this is long enough to do a fit here. So let's do, what you want to do is select the data, just click on it with the mouse. I had it clicked on before. So then do math, and then choose fitting. So in the fitting menu, you can choose to fit it, say, with an exponential. I see a little bit of noise here going on, so I might choose to start this after 250 seconds. You can play around a little bit with the particular time that you're choosing to do your fit, and then you can do your fit. Sometimes you need to do an estimate, then do a fit to get an actual good fit, and you should be able to see a good agreement here. This way, you're getting your rate constant K rate off of the software of the computer. And so that's pretty easy to do. Sometimes we do a shorter interval. If you do a shorter interval, you could do a linear fit just for the change of concentration as a function of time. But as long as we do runs for about at least 10 minutes or so, usually we can pick up this exponential decay and do a nice exponential fit. So then once you're done with this, you hit OK. And once you want to get some of your files, you would come back to the ProData viewer. And your runs, like the kinetic runs, are saved under run. So you might, after each trial, note that the next kinetic run that we do would just be the number with the next number down. So the next run we do will be 00378. So you might keep track of which kinetic runs are yours, so you can extract those later or whenever you're finished for the day. The baselines are saved. Usually we don't need to export the baselines. The only other file you might export are the spectra. Those are saved under spec. So under spec are the spectra files. So whenever you have a file you want to export, you just click on it, right click, export data, and then export it as a simple CSV, hit OK. This computer not connected to the internet for safety reasons, so what we'd have to do is just use a flash drive or something to get the data off the computer. Okay, so I think that's the basic run through for data analysis and data extraction.